We got a new word. We're looking at 2-4, which is page 11. Yes, say it again.
Differentiable.
Differentiable. That's my new word, people. Connecting differentiability and continuity. Wow. Determining when derivatives do and do not exist. What? A function is differentiable at x equals a if blah, blah, blah. Here's what it is. Differentiable just means has a slope. Has a slope. Differentiable comes from the word derivative. Okay? A function has a derivative, is differentiable if, I'm actually going to come back to this. Let's talk about these 4 things first. Let's talk about what makes something have a slope. Ooh, this says how f prime of a might fail to exist. We got 4 different examples. You guys, would you say my slope over here is negative?
Yes.
Great. Would you say my slope over here is positive?
Yes.
Great. What would you say my slope at 0 is? 0. We don't quite know, right? Daria, are you with me? Yeah. If I'm here, if I'm a negative slope here, at the point, wouldn't my slope be like, I don't quite know where to go? This is going to be not differentiable. This is not, well, let's write that word. Differentiable, at x is 0. And our rationale is we have a corner there. At that corner, if you would, Brady, would you hold this pen for me? At this corner, would you put the pen on my corner and then wiggle it? Like, couldn't that slope be any of those? You know what I'm saying? We can't have a slope at a corner. You guys okay? Is it differentiable over here? Yeah, the slope's negative. What about over here? Yeah, it's just at 0 that we've got this new word that's not differentiable. We can't have a slope at that corner.
So things are always different.
Here we go, you guys. What about over here? What would you say the slope is on this left side of 0? Negative and getting more negative. What about that slope on the right side of 0? Positive and getting less positive, actually, right? What would my slope be at 0? We don't know. We don't know what it's going to be because it's at something called a cusp. Now, you guys, this is also not differentiable at 0 because it's got something called a cusp where curves come together. Aiden, if you call this a corner, great. Could not care less, neither does AP. Sean, if you call this a cusp, not a problem at all. We just need to know at any sharp edge, at any point, we will never have a slope. It is not differentiable. You guys, what is the slope of my tangent line over here? Positive. What about over here? Still positive. Less positive, but they're both positive, right? But what about at 0? What is my tangent line looking like there? It's a vertical line that has an undefined slope, right? If differentiable means slope, and the slope is undefined, this is also not differentiable at x is 0 because of that vertical tangent line. So maybe you want to draw that in, and also not differentiable at x is 0.
Thank you.
You guys, what about if I've got a discontinuity? What if I'm here? What's my slope over here? 0 because it's a horizontal line, hoi, right? What's my slope over here? 0. What's my slope at 0? Like, I have no idea. The function doesn't, what? You want me to put a slope over here? I don't know what that's going to look like. Doesn't exist. So again, not differentiable there either. I kind of wish that there was one more graph. What about this graph? And to your point, Soph, I'm going to move it away from 0. Let's go at A. Do we have a slope prior to A, to the left of A?
Yes.
Yeah, those are positive. What about to the right of A? Positive, great. What about the slope at A? Doesn't exist. There's a hole. I can't have a slope if the function doesn't even exist there. So this is my 5th example. Just because a function is continuous. Hold on, let me back this up. Mr. Heald, would you say that this graph is continuous? Yeah. Did I have to lift my pen? No. So that one's continuous. What about this one? Yeah. Continuous. What about this one? Yeah. Continuous. Just because it's continuous doesn't mean it has to be differentiable, people. It is a long word. I'm okay if you write DIFF. I'm fine with that. If a function is differentiable, it must be continuous. "30 seconds. I'm going to give you 30 seconds. Try this actual AP question. So let's look real fast. They gave us some info. We've got a vertical tangent at the point 2, 0, so I'm going to draw that in. We have horizontal tangents at the point 1, -1, and at 3, 1. Where is it not differentiable? Not dicey? You're saying at 0, which they didn't talk about, 0, there's a big jump discontinuity. Do you agree? I cannot know the slope at 0 because the function is discontinuous. So I like 0. And then you said at 2, we got a vertical tangent. Slope is undefined, so I agree with 2 as well. So I'm getting rid of that guy. I don't like that guy. Don't like that guy. What about 1 and 3? What's my slope at 1? 0. What about my slope at 3?
0.
Is 0 okay? Yeah. Sure. So B it is. Ugh. So as we are looking at page 11, go flip back up to that top. The notation for something to be differentiable. No, you don't have to write this whole thing. I'll show you how it shortens, but let me just talk to you about why this is meaning differentiable. You guys, this is all fancy. I agree. We do not like this. This is fancy for the derivative, right? This is fancy for the formal definition of the derivative. Derivative just means slope. This is saying for something to have a slope, for something to be differentiable, the slope from the left side has to equal the slope from the right side. As I look at this graph, what's the slope over here? Negative. What's the slope over here? That's why it's not differentiable at 0, because as I approach 0 from the left, the slope from the left is not equal to the slope from the right. That's a lot. So here's what I need you guys to say. Slope from left, I would put that underneath this little definition. I apologize, I didn't leave you as much room. Slope from the left does not equal, must equal the slope from the right for it to be differentiable. And I'm going to put a little circle around that. Good, I'm glad, Brady. Here, I gave you a piecewise function. A piecewise function means that I could have a break there. I could have a discontinuity, or they could come together nicely, right? Field and Hetler, you think you can stop touching each other? Okay. And it's asking, is it differentiable? For it to be differentiable, what are you thinking? Yeah.
It's not continuous, there's no...
She's saying, hello, at 1, my function doesn't even exist. So my girl, Sophie's going to say, f of 1 does not even exist. And what that means in a graph, Soph, do you agree? Our graph could look something like this, or it could look something like this. I'm sorry, it doesn't even have to be a cusp or a corner. But regardless, you're saying, f of 1, there's a hole. Can we have a slope at a hole? No. So we're going to say f of 1 does not exist. Does anyone remember what 3 dots do? No. Say it again, Daria. Therefore. Yeah, that means therefore, you guys. And I know, right? Therefore, h of x is not differentiable. DIFF, I'm fine with, at x is 1. Let's examine this graph. Bondi, what do we think?
Absolute value of a corner, so not different.
So, because since I said at the origin, you're saying, what does absolute value look like? What does that graph look like, buddy? Boom, boom. I love it. He's saying V. Doom, doom. You guys, let's just draw that in. Because what I said, Bondi, is let's examine the function's continuity. Would you say this function is continuous, Bondi?
Yes.
Because we would say f of 0 equals, what would you get when you plug in 0 into that function, bud? 0. It's got the point 0, 0. So it's to Soph's point, like, okay, at least we're continuous. Why is it not differentiable? It's because we've got this corner, right? Here's the deal. AP is not going to only accept there's a corner at 0. I sure wish they would. Here's what I need to go tell you. Let's write this out, what that would look like with the notation instead of just saying there's a corner. Dang it. We're going to say the limit as x approaches 0 from the left of my function. What do we say does or does not equal? It does not equal the limit as x approaches 0 from the right of my function. that is saying that there's a corner. So we'd say even though it's continuous, we proved it's continuous, because the slope from the left didn't equal the slope from the right, we're going to say it is not differentiable because of a corner at x is 0. Okay, being a little redundant. Go for it, Graham.
Continuous and differential.
Just because it's continuous at x is a does not guarantee it's differentiable. Ooh. We sure did. Differentiable. We sure did. I was real redundant. Take a peek. I said by looking at the graph, I'm going to just help you. What about this graph? This is the graph of 1 over x. Look what they asked without using words. What's f prime of 0? Yeah, there's a vertical asymptote there, right? So we'd say f prime of 0. I'm okay with you just saying does not exist because vertical asymptote at x is 0. We don't need to get into the notation on that ditty. And we're going to skip this one. This first one, I want to talk about h prime of 7 first. If they're wanting the slope when x is 7, would I look at the top function or the bottom function? The bottom, because 7's bigger than 2, right? You guys, the bottom function is y equals 5. What would that look like? Horizontal line, right? Y equals 5. What's the slope there? 0, right? So what's h prime of 7 going to be? Love it. And maybe you just write yourself a little hoy note, right? Because that's it. That's it. Now I'm going to really, really sassy up. What if I ask for h prime of 2? 2 is where this break happens. We could have a break and they feed into each other. It's continuous and my slope is the same from both sides. Could be like this or it could be like this.
You say it doesn't work because the slopes don't equal.
Well, we don't know about their slopes yet, do we?
I think it's 3.
Ooh, I think you're right-ish. You guys, does h of 2 exist?
Yes.
When x is 2, what would you get? Yeah, and I'm actually going to put it on both ways. That's okay. Say that again, Nels. What do we get? 3 times 2 is 6 minus the 1 gets me 5, right? What about 2 from the right-hand side? My bad. It's also 5. Therefore, is my function continuous if from the left and from the right, they both equal 5? And h of 2 is 5. I feel good about that. But continuity doesn't necessarily mean differentiability, right? Just because it's continuous doesn't mean it has to have a slope at that point because there could be a corner. So, to Daria's point, what is the derivative of the top function? What is the slope of the top function? This is just y equals mx plus b. What's the slope of the top function? 3. Y equals mx plus b. What's the slope? You already told me what the slope of the bottom function was. 0. Do my slopes equal? No. So let me tell you what this graph would look like. As I'm approaching 2, the graph looks like this. This is the 3x minus 1. And then it looks like this at 5. This is 5. So you guys, this is continuous. We proved it. At 2, they both equal 5. Is there a corner there? Yes. Therefore, h prime of 2 does not exist. The slope at 2 does not exist. Let's try that notation real fast. That notation's going to say the limit as x approaches 2 from the left side of this function, right? I'm going to put my 3x minus 1. Does or does not equal? Does not equal. Thank you, buddy. The limit as x approaches 2 from the right of the other function. And again, you might be like, what? But when I plug that 2 in, I get 5 equals 5. I hear you guys, but what we got to remember is that the slope from the left did not equal the slope from the right, now that we're talking about those limits. Yes, sir. Let's take a peek at this guy. Figure shown to the right has a vertical tangent at 2. I like to draw those in. Horizontal tangent at 4. Which statement is false? Which statement is false? Is my function not differentiable at -1?
It's true.
Because we have jump discontinuity. I agree, that is true. My function is not differentiable at 2 because we have a vertical tangent. That's also true. Brady, you're saying C is not differentiable at 4 because we have a horizontal tangent. What's my slope there?
0.
Yeah, that's okay. Slope is 0, and that's okay, so that's false. Do we agree it is not differentiable at 6 because we have a hole there? Removable discontinuity. Very good. Last thing here before I do a candy question. Guys, I really just want to focus on how to analyze this real fast. Which of the following statements is true? Which one is true? My function is not differentiable because it's not continuous. Continuity, we're just going to plug in 5 to the top and to the bottom, right? Into each of them. What do I get when I plug in 5 to the top? Yeah, 5 squared minus 20 is going to get me 5. Be careful. They're trying to throw you off with that negative sign. If I plug my 5 in there, does that mean, is this equivalent to this or this? The first one. Okay, you guys, because they didn't put this negative sign in parentheses, that negative sign is not getting squared. It's only the 5. So what would that simplify to be? -5 plus 20? I'm sorry, -25 plus 20 is -5. Is my function continuous? No, from the left we got 5, from the right we got -5. It is not continuous. What's our problem?
If it's not continuous, it can't be different.
Agreed. Perfect. Whew. If the limit as x approaches a is L, if I draw a graph of that, and I agree, I'm a picture girl, could that be this picture? Does the limit as x approach a equal L here?
Yeah.
Could that be this picture? Could that be this picture? Are all these limits still L?
Yeah.
Do you agree all those have a limit of L? Whew. So, if my limit is L, I just drew 4 different examples of when my limit equals L. Which of the following must be true? Whew. Does my slope have to exist? This guy doesn't have a slope there. This guy doesn't have a slope there because of the corners, right? My slope does not have to exist. Does it have to be continuous? No, it limits what happens as I approach it, so it doesn't have to be continuous. Does it have to be defined? What does that mean? Yeah, does it have to have, when x is a, have a point? That means that my function's defined there. No, it doesn't have to be defined. You can still have a limit there. Does f of a have to equal L like it does in that picture? No, because f of a doesn't equal L here, but my limit did. This is hard. That one was none of the above. Pictures help me as well.